My name is Lawrence Saint-Onge. I'm a president of LSO Consulting. I'm a member of SMPTE for more than 30 years, and I was recently elected as chair of the Toronto section. I have a bachelor degree in electrical engineering. I provide consulting in media technology, live event, broadcast, virtual augmented and XR reality, immersive audio video environment, system design, engineering, and acoustics. For more information, you can have a look on my old website. And for some of the project I worked on, it's House of Commons, Senate, Ballad Box, Cirque du Soleil, Warrior Studio, TF1, and more. So for following up on SMPTE, there's SMPTE Toronto updates. There's new board managers. On the Toronto section chair, myself from LSO Consulting. There's past chair, Tony Meriker from Mayor Tech System, Secretary Treasurer Craig Jasmine from CBC Radio Canada. 3 new manager for 2-year terms, Noor Hassan, Amazon Web Service, Roy Folkman, Synesis, Angèle Rochelot-Bourgeois from Bell Media. 3 new managers for 1-year term, Jamie Cayero, Chorus Entertainment, Randy Conroy, Independent, Jason Ross, Telestream. And also from West Canadian subsection, Chair Rick Sutherland, Practical Post Consulting, Secretary Treasurer Brian Gattensby, Chorus Entertainment. And I like to excuse myself if I mispronounce some of the name. So to continue for the meeting, the order of the day, the meeting is arranged by myself and Tony Meriker, but I will say that Tony, I'll give all the credit to Tony. And our meeting protocols, each presenter will share their experiences and new development on ATSC 3.0. Question will be during panel discussion at the end. There will be a Zoom portal question box and no break between the presentation. And on that note, I'll give the meeting control to Tony.
Okay, so what I'm thinking I was going to do here is take a couple of minutes, just go over a couple of slides on ATSC 3.0. I don't know where and how fluent our audience is. So I'm just going to give you a couple of slides, and I hope I do it justice, but I'm sure Madeline and Urs will correct me along the way. So ATSC3, it's Advanced Television Systems Committee, and there are a couple of logos that are associated with that particular name. So if you see that ATSC3 logo, then that's the Advanced Television Systems Committee. It's also known as Next Gen TV at times with that logo that's associated with it. So if you do purchase a TV that has a tuner, then you'll likely see the Next Gen TV logo plastered all over the box. So ATSC 3.0 is really the next generation digital terrestrial broadcast system, which is over the air. That brings several improvements over the previous or our current ATSC 1.0 standard. That includes better reception, which I can agree to. Up to 4K Ultra HD resolution with movie theater quality sound, which they use Dolby AC4, mobile viewing on the go, and on-demand content. Hang on one sec here. Why? So there's a couple of things, and this part I don't know if that's for real, but I know there was a spectrum repack that happened to make more room for the cellular guys. So some of the TV stations had to change their frequency, and I think there's a bandwidth issue. So the new technology allows for a better stream with less bandwidth. But there's also a big component to this, which is there's new business opportunities for broadcasters. A better user experience. There is an interactive component to when you watch one of these channels. That's direct to mobile. You know what? There might be ATSC 3.0 chips enter into mobile units or mobile devices. Direct to vehicle, remote educational delivery, first responder network, and good old internet delivery of internet services to areas that are not serviced. Where is ATSC 3.0? Well, in the United States, there are 74 markets currently offering ATSC 3.0, which is a fair chunk of the population in the US. South Korea paved the road to ATSC 3.0 by adopting UHD back in 2016, and they launched 4K broadcast in 2017 of May. And now 80% of the population in South Korea are using or watching ATSC 3.0. Jamaica, Brazil are both in, I'm not sure how much they're in. India is exploring direct-to-mobile services. Mexico focuses on educational use cases. And then Canada, we have Humber College. They have 2 transmitters, but Urs, you can correct me. And it's a offering ATSC 3.0. They are a test lab for testing various components of ATSC 3.0. So yeah. How do I receive it? Well, it is over the air. Televisions have to have a tuner. It'll either be next gen displayed or there'll be specs inside the specification that says, well, I've got an ATSC tuner inside. Sony, Hisense, LG, and Samsung are some of the TV manufacturers that actually have ATSC 3.0 tuners. But if you have a TV, an older TV, there are set-top boxes that are coming out now. Silicon Dust has a home run version that has, I think, 4 tuners, PVR device that sits on top of your TV that plugs into your antenna and will do ATSC 3.0 and more because it's PVR and it would be classed as a cord cutter device. Electronic outlets are featuring many versions of set-top boxes, like the various, your favorite online shopping location will get you that. And then there's the website atsc.org. There's a lot of information there, and I encourage you to park your browser there sometime and just read up on all the information that they have about this technology. So 2 presenters tonight. We have Madeline Nolan. She's the president of the Advanced Television Systems Committee. And we have Urs Schusko, who is the director of Humber College Broadband Convergence B2C Lab. So first up is Madeline. And Madeline's bio reads this way. She is president of Advanced Television Systems Committee Incorporated, a 15-year industry veteran who is widely respected for her conscientious building leadership style. She chaired the technology group that oversees the ATSC 3.0 next generation broadcast standards before being named the president in 2019. Previously, she chaired the various ATSC 3.0 related specialist groups, ad hoc groups, and implementation teams since 2012. Madeline began her career in the television industry with Back Channel Media Incorporated, an interactive television technology developer, and became involved in ATSC projects. In 2012, she moved on to product and project management role at Telview Corporation before joining LG Electronics CTO's office in 2013. Nolan represented LG in a variety of industry organizations over the 6 years. So Madeline, there, I'm going to let you steal the presentation from me, and you can take it away.
Great, thank you very, very much. And I trust people can see the screen. I'd like to open by saying, first of all, thank you so much for this opportunity to speak to the SMPTE Toronto chapter. And I would also like to encourage people, please ask questions in the middle of the presentation. Interrupt me anytime. I'm watching the Q&A as well as the chat box, and I'm happy to answer any questions. Unfortunately, I won't be able to stay for the whole Q&A period, so I would say that if you have a question that comes to you during the presentation, ask away. If you have a question that comes to you after the presentation, probably Oris can answer it. And if for some reason, Oris wants to pass it back to me, he can definitely do that, and I will respond by email over time. So with that, I'll go ahead and get started. I think that already our hosts gave us a good introduction. ATSC is the Advanced Television Systems Committee. Some people think that A stands for America, but it doesn't. ATSC is an international organization, and ATSC 3.0 was developed by engineers all over the world. There are approximately 175 to 100 member organizations that are part of ATSC across the entire broadcast ecosystem. Some people were asking about ATSC 1.0 and is 3.0 backward compatible with 1.0. And I would challenge you to find anything in this slide which is backward compatible with today's technology. So ATSC 1.0 was developed when we had DOS 3.1, dial-up modems, cell phones that were 2G, and VCRs, and we also had ATSC 1.0. So understand that this is a 25-year-old system and then some. And consumer demands have certainly promoted an opportunity to change the technology, in fact, a challenge to change the technology. So consumers are definitely moving to devices and TV services that enable on-demand viewing on many different devices, TVs, phones, computers, tablets, in lots of settings, at home, on the go, with 4K pictures, immersive sound, lots of content, recommendation engines. And streaming services are delivering these benefits, and consumers are shifting their viewing to screen time to streaming services. So in my mind, this is almost watching consumers vote with their feet. They are telling us they want these things. And so broadcasters also have to deliver these benefits in order to maintain the level of service that the public expects from free-to-air television. So along comes ATSC 3.0. And the goals of ATSC 3.0 were to add value to the broadcasted service platform and to address changes in consumer behavior. And one of the things that was pointed out just a minute ago is that it's not just about television anymore. And I want to just point out that that's one reason why you see those two logos, the ATSC 3.0 logo and the Next Gen TV logo. ATSC 3.0 is a superset of all the things you can do with this technology, whereas the Next Gen TV logo is really referring just to the television services that broadcasters can deliver using this platform. Some key advancements were already mentioned, so I'm not going to dwell on this. Additional capacity, better reception, hybrid services, enhanced consumer experiences, and the new business models. I am going to spend a little bit of time on that second one, better reception, because this is a really key element of the new system, which allows for a more efficient system. And I'll explain how that works. This is one of two somewhat technical slides that I want to share with everybody. We are very close to the theoretical limit of efficiency of spectrum usage. So what you see there is the blue line, and that's called the Shannon limit. And it's the theoretical limit of the amount of data a spectrum band can carry relative to the robustness of the signal. So when you're delivering data over the air, there's always this trade-off between how strong is your signal and how much data can you carry. So in this diagram, the x-axis shows the most robust signal on the left and the least robust signal on the right. And as you might guess, the most data is on the y-axis toward the top, and the least data is on the y-axis toward the bottom. So as you work toward the lower left side of this particular chart, you're sending less data, but boy, is that a strong signal. And as you go to the upper right side of the chart, you're sending more data, but the signal is less robust. So you could imagine that you could be using this upper right part of the chart for fixed TV services with large antennas that are on the rooftop. And you might be using the lower left side of the chart for mobile services, which require a more robust signal, but perhaps you don't need 4K video for a smaller screen. It's important to note that ATSC 1.0 and other first generation systems existed against the Shannon limit right around that point. And ATSC 3.0 and most second generation systems operate much, much closer to the Shannon limit. So just looking at this chart alone, you can see that if you kept the same robustness, you'd get about a 30% boost in data capacity by moving from 1.0 to 3.0. Another important distinction between 1.0 and 3.0 is the single carrier versus multi-carrier design. I see a question that says, is there a roadmap for harmonizing DVB with ATSC? That's an excellent question, and I'm going to take a little sidebar to talk about that for a minute. In my personal opinion, the ATSC and DVB perform very closely with respect to the Shannon limit, so their physical layers are very, very similar. The upper layers are where I see an opportunity for harmonization. For example, ATSC 3.0 and DVB-T2 are sharing the same watermarking technology. There's a lot of interest in DVB-I and whether that can be a good announcement system for ATSC 3.0 and next-gen TV services. Also, those two systems share the VVC codec, the MPEG-H audio codec, the HEVC codec, and others. And the interactive systems are very similar. HBB-TV and ATSC's interactive systems are both based on W3C technologies. So there are a lot of similarities, but unfortunately, you can't buy a DVB-T2 television and bring it into an ATSC3 market and have it just work. So they're close, but not quite, I would say, harmonized. But that said, folks from DVB and from ATSC are interested in convergence as use cases permit and sort of on a case-by-case basis and doing the best we can with that. So the single carrier versus multi-carrier, the ATSC 1.0 uses a single carrier physical layer design, and I'm using sort of the American and Canadian football analogy here. 8BSB relies on one robust carrier. And if you imagine that your football player is trying to get across the goal line and you've got one really, really big dude, it's hard to stop him. But if you do stop him, there's no pictures and sound. Whereas the multi-carrier system, which is the OFDM system that ATSC3 uses, relies on lots and lots and lots of carriers, thousands of carriers. And as long as enough of them get through, then the consumers are going to get solid reception. So what that means is that each carrier has its own method of avoiding interference, which allows some of the carriers to get through in almost all the circumstances. That's one of the reasons why ATSC 3.0 is so much more robust and therefore can carry more data. Broadcasting has a key role in the data-hungry world. I just want to set this table for a minute. So we have a high-power, high-tower infrastructure that allows for sustainable transmission of point-to-multipoint services. And this can include television and non-television use cases. Broadcasters can fill an important role in a heterogeneous network of networks. So if you imagine that you have certain use cases that are really well suited to one-to-many, you can use broadcast for that. Whereas if you have use cases that really need a one-to-one, like text messaging and other unicast options, you would use a different network, for example, the cellular network. So the global DTT community can work together to find these common interfaces between the different digital terrestrial transmission radio access networks and other global unicast networks. And ATSC, to the point that Ward asked, we are welcoming opportunities for collaboration as we work together to solidify the role of broadcasting in today's media and data delivery landscape. And this is just a slide to talk a little bit about the sustainability aspect of digital terrestrial broadcasting. This is a chart that shows the energy consumption needed in order to deliver some media to an audience. The bottom part of these bar graphs are how much energy it takes to just send the data, and the top part is how much energy does the television itself use. And you can see that with the digital terrestrial television broadcast, the amount of energy needed in order to deliver quantity of data to an audience is orders of magnitude less than over the top and via IPTV. So I think it's important to understand the power and significance of our high power, high tower infrastructure that we have across the world. In fact, I think television services reach roughly 82% of the world's population. We can deliver the data and the services and the media services to these folks in a one-to-many fashion in the most sustainable way possible. So the question becomes, is now the time to upgrade to a new digital television system? So today's second generation systems are not going to be replaced anytime soon. They are very future-proof. And ATSC 3.0 and other second gen systems are virtually at the Shannon limit, which means that there's almost really no improvement for 3.0 over what we have now. DVB is in the same spot, and the new Japanese standard, which is being developed now will probably be in a very similar spot as well. We can't get that much closer to the Shannon limit. So also, the multi-carrier system that I described earlier enables a gradual evolution of new services over time. You can imagine that some carriers are carrying today's services, and tomorrow, some carriers will keep carrying those services for legacy devices, and other carriers will be carrying brand new services. So we can have these things all going together in the same RF band to allow an evolvable situation for our viewers and for our businesses. And it's interesting, no country or standards development organization is seeking to eclipse second generation efficiency in the physical layer. There are no ongoing projects right now to get closer to the Shannon limit. So by upgrading to 3.0, broadcasters are really demonstrating their commitment to the high quality free TV services for generations to come. And with no revolutionary physical layer innovations on the horizon and the increasing audience expectations, now might be the right time to upgrade. Talking about consumer-facing opportunities, and this was touched on just shortly before, the broadcasters can work with state government education departments to provide distance education services. And one example among many, these are quotes from the news, the partnership is expected to spur further development of the use of 3.0 datacasting to provide distance learning services for K-12 and college students in rural communities who lack sufficient broadband access. Datacasting for distance education is also being considered for incarceration facilities, corporate training facilities, and all sorts of other use cases where people need information. Datacasting is another interesting one. Besides watching television, we can deliver any kind of data. ATSC 3.0 is an IP-based system. It just delivers IP data files. That's all it does. So software and firmware updates, navigation map updates, enhanced GPS, digital signage, as well as, of course, linear television services. Here's an example of an eGPS, in other words, enhanced GPS service using 3.0. The drone's accuracy improved from plus or minus 1 meter to a margin of error within 2 to 3 centimeters by enhancing the GPS triangulation that it was able to get using the ATSC 3.0 signals. Another opportunity is in Detroit, Michigan. Right now, there is a Motown 3.0 test trial going on, and it's possible for automotive fleets and dealers and OEMs to come to Detroit and test automotive use cases with ATSC 3.0. There's also the first responder data services. So certainly we can deliver advanced emergency messaging to the regular public, but we can also have messages that are specifically private for first responders. Information to fire, police, and other first responders in times of need. An example took place during the 4th of July celebrations in Washington, D.C. Based on the next-gen TV broadcast standard, Incident 1 layered a new secure wireless network on top of the existing communication procedures to facilitate interagency sharing of data at unprecedented levels. Again, with a one-to-many system, it really doesn't matter how many people are consuming the data. We have a scale of efficiency that's infinite in terms of device receiving. And we also have PBS North Carolina, which is working on a replacement system for a very old pager system. PBS North Carolina, jointly with its partners, has a grant awarded by the U.S. Department of Homeland Security. The emergency digital paging system utilizes digital ATSC 3.0 technology. And this was discussed actually at Humber College at a recent event. A little bit about what's going on with the deployment. South Korea, as was mentioned, launched in 2017. Their goal was to get it on the air in time for the Pyeongchang Olympics in 2018 in February, which they did. and they're currently reaching roughly 80% of the population with services. In the United States, as was mentioned, about 74 markets have launched. We are looking to have New York's DMA launched this year, which will get us very close to 75 to 80% of the population able to receive ATSC 3.0 services in the United States. Jamaica has launched. They are on the air in Kingston and in Montego Bay, and they're hoping to complete their launch as soon as possible. They're working on devices and the campaign for education of consumers and other pieces that need to be in place to finish the transition there. They're actually transitioning from analog to ATSC 3.0. They're skipping the first generation digital altogether. Trinidad and Tobago are doing the same thing. They're expected to get started this year, and they have a very ambitious completion date of 2026. They're also going straight from analog to 3.0. Brazil is working on a TV 3.0 project, and they've already made a bunch of selections for what their TV 3.0 system is going to include. Most of the selections made up to now have been from the ATSC 3.0 standard, including the transport system, which is Root Dash, one of the audio systems, MPEG-H audio, the IMSC1 caption system. They also chose VVC, which ATSC is currently adding to the standard, and ATSC emergency messaging. The one that they have decided they're not going to use from ATSC 3.0 so far is the interactive system, because they have a homegrown one, which they're going to keep. And they haven't yet made their selection for the physical layer. So right now they're in the middle of testing. And as shown in the third bullet, there are 3 systems that are being tested for the physical layer. We expect that they will make a decision about that in Q1 of 2024. And they have a presidential executive order to launch Brazil 3.0 in 2025. India is working on direct-to-mobile broadcast for $1 billion, if you can put it that way. So about 1.2 billion or so smartphones are in India right now, and the majority of people will watch over-the-air linear television on their cell phones over the MNO's network. And it actually puts a big strain on the networks, on the cellular networks, when there's a big event such as a cricket match. So they're exploring opportunities for using the high-power, high-tower infrastructure to deliver direct-to-mobile services. And they're looking at ATSC 3.0 as at least one of the possibilities. There is a 6-site single-frequency network set up in Delhi, which is anchored by one of the high-power, high towers of the public broadcaster, Prasar Bharati. To be clear, India does not have a mandate to make a shift or any kind of transition at all, and there's no mandate for India to use 3.0, even if they were to make a shift. It is interesting, though, that TSDSI, which is their standards development organization, have adopted ATSC 3.0 as their own standard, which paves the way for a potential Indian national standard of 3.0. That, of course, is TBD. I'm going to not even spend any time on this slide because Oris is going to talk about this in great detail. But I do want to spend a little bit of time on this one. What is going on with next-gen television set sales? One person asked a question early on, can you get ATSC 3.0 services with a 1.0 television set? Answer is no, not without a converter box, upgrade accessory, set-top box, gateway, or whatever you want to call it. The Consumer Technology Association has put out its predictions for television sales, specifically next-gen TV sales, over the course of the next few years. And they are looking at sort of an inflection point in the time frame of 2025, 2026, when the majority of televisions sold in the US will have next-gen TV in them. These little orange bars down here are their predictions for what's going to be in terms of set-top box sales. And they confess that they don't have a lot of evidence, or I should say, not evidence, but a lot of experience with set-top box sales. So this is sort of a best guess. But the hope is that by the time we get around to 2026, 2027, the majority of US televisions in the field will be 3.0 capable. A little bit about the set-top boxes. This Atlanta DTH by Tolka set-top box with a next-gen TV logo is now available. And this Zinwell box just earned the logo, and the product is coming out hopefully this fall. I will say that one of the boxes that was mentioned at the beginning about the, for example, the Silicon Dust HD Home Run box, that one actually doesn't have the logo yet. And what that means is that it's not quite ready for the digital rights management piece or the encryption piece. And I don't know quite what Silicon Dust wants to do as far as that, but my hope is that they will be adding that piece soon so that those that are in markets where broadcasters are using the encryption system will be able to get those services as well. But if you have a box with the logo, then you will be able to deal with the encryption pieces. Is there a backup plan if a tower is turned off during forest fire, as we experienced this summer? So Laurence, I don't really know how that works. In the US anyways, we have found that the television broadcast infrastructure, including the high power, high tower, is very, very resilient and considerably more resilient than the cellular system. As far as I know, I don't know exactly the details of that particular incident. What DRM services are supported? So in the US, broadcasters are encrypting their primary main channel services. And the boxes and televisions that have the NextGen TV logo are built with the capability to decrypt those services with no license keys, no license fees, nothing that the consumer has to do. They are built already to do that. You do not have to connect them to the internet. So when it comes to DRM services, the broadcasters are free to encrypt any of the services that they wish. They are, at least in the United States, required to provide their main channel free to air without needing a license fee, without needing an internet connection or anything like that. And so in many markets in the US, they are encrypting that service, mostly as an anti-piracy move. Many of the large content producers, such as the major sports networks, expect that there will be encryption on the services in order to protect their content. We have another question. Broadcasters wanting to reach Gen 1, 2, and 3 receivers will require multiple transmitters. Is that correct? How about the transmission towers? What is the typical range of 3.0? So the answer is yes, you do need multiple transmitters. However, what broadcasters are doing in the United States is each one has one transmitter and they are channel sharing. So they will pair up where one broadcaster will transmit all of the 3.0 services and the other broadcaster will transmit all of the 1.0 services so that 1.0 and 3.0 are both on the air at the same time, and each transmitter is only doing one thing and each broadcaster has only one transmitter. And the typical range, that is very much up to how robust the signal is. If you recall from the slide about the Shannon limit, broadcasters can choose to have a very, very robust signal, which would presumably have a higher range, or a less robust signal, which would presumably have a smaller range. But I think Orest's team is also working on these kinds of proposition questions, and he would probably be also a very good person to ask that question or answer it. ATSC 3.0 is a suite of standards. There's a bunch of documents that comprise the standard. What's good about that is that we can change one or two without changing the whole lot. For example, I mentioned we were adding VVC video codec, and here you can see A341, the video HEVC. We have an opportunity to update that for VVC without changing all the other components of the system. We have some major ongoing projects within ATSC, some of which Orest is going to touch upon. One is the CMAP, another is VVC, which I mentioned, the Broadcast Core Network, ATSC 3.0 and 5G harmonization, and an inter-tower communications network, and Orest is involved in all three of those. So although I have some slides on that, my time is just about up. So I'm going to basically run through these very quickly because I know Orest is going to cover them in a lot of detail. So here's VVC, what we're up to. A lot of this has to do with what Brazil wants to do. The Broadcast Core Network envisions a new nationwide wireless data delivery network that's completely interconnected across all the transmitters. ATSC TG311 has been studying 3.0 and 5G harmonization with the concept perhaps of offloading traffic, like I mentioned in that India use case, where folks in India are watching linear television on the cellular network on a one-to-one basis. If they could move that traffic to the high power, high tower, then that would be a big relief for the cellular network. So this ad hoc group was studying different technical architectures that could make that work. And the inter-tower communications network is an idea where you are using the towers themselves to get data to other towers, which would then be transmitted to the ground. And again, Orest has a lot of information about this in his slides. For more information about ATSC, you can find out what's going on with the latest developments. The ATSC monthly newsletter, which is free, you can sign up. You can opt out anytime. And for easy reference, we have a column in the newsletter that helps you find out what's going on with the standard, so you don't have to sort of check back. Another website that I want to bring to everyone's attention, particularly with respect to what's happening with the deployment in the United States and with what television models are available, is watchnextgentv.com. I'm going to put that into the chat window for you. The ATSC website is very, very good for kind of B2B communications, and the watchnextgentv.com is very much focused on B2C communications. And with that, I'm going to wrap it up and say thank you. I see there's some questions in the chat, and I will answer those by typing in text, and I will pass it back to our hosts.
So, Madeline, before I let you go, I have a question because I don't know that I could type this question out. So if it's deemed that the networks or the broadcasters are using one transmitter to deliver, like call the Buffalo market, they've got 5 HSE outlets. I'm assuming then, because I know that the tower is on Grand Island, so 5 of them are pumping their signal through one tower. Is that what you're suggesting?
That's exactly right. So
Okay.
Here in the US, we don't have any extra spectrum in order to deliver both of the systems at the same time. So we have to find a way to do it within the spectrum that we have. And you correctly pointed out that we even had a repack, so we have less spectrum than we even had before we started this transition. We have to figure out how to get it all done. Unlike South Korea, where they got brand new spectrum in order to simulcast, same thing in Jamaica, they've got spectrum to use. Brazil is going to be in the same boat as the US. Much of the country, the major markets in the country, they will have to do channel sharing. So in the simplest scenario, you have 2 broadcasters working together. One broadcaster says, I'll do all the 3.0. The other broadcaster says, I'll do all the 1.0. And they channel share that way. In more complicated scenarios, which are honestly more common, is that 4, 5, and 6 broadcasters will be part of the channel sharing agreement. One broadcaster will be 3.0, and they will host all the 3.0 signals for all 6 or 5 partners, and all of their 1.0 services will be distributed among the other partners. So all the other partners are carrying 1.0, and the one stick is carrying 3.0, which is what you're seeing in Buffalo. We see it in Boston as well. I think there's 5 or 6 HD services on the Boston transmitter, plus 1 or 2 SD services, all on one transmitter, which it kind of speaks to how really robust this system is. It's extremely robust, and the capacity is very, very high compared to 1.0. Not only do we have the benefit of the better physical layer, we also have the benefit of the more advanced video codecs. Simply moving from MPEG-2 video codec to HEVC is massive all by itself.
Would it be then safe to conclude that the flip will happen, that when everybody's own tower will flip to 3.0, and then the combined tower will do 1.0 just for the legacy sets out there? And
That's certain. Oh, beg your pardon.
I was just going to say, would that lead to, because now there's one service per tower and their towers are higher in the air and they might be able to pump out more power if that's what they choose to do. And where I'm going with this is that Toronto, some areas are on the fringe, shall I say? So I'm just wondering whether they ever would increase their power so that some areas that are kind of on the fringe would be able to get a better signal.
Well, I would say that the regulatory bodies that govern the sort of geolocation of what the tower is allowed to do is one thing. What the broadcasters can do is they can make the signal more robust within the geographic area that they have. So, for example, in the Boston area, where I talk about that because I used to live there until just recently, and the tower carrying the 6 or 7 services was farther away from my house and less optimized for the direction my antenna was pointed, and the signal was stronger than on the 1.0 towers, which were closer to my house and optimized, and my antenna was optimized for that direction. So I think that in my personal experience, the ATSC 3.0 signals are much more robust. The reception is very stable, but there is, of course, the regulatory question in terms of what area is a broadcaster permitted to deliver a signal to. And I can't answer all those questions. I'm certainly not an expert on the regulatory side of things.
Cool. See, I couldn't put that in words, so that's why I had to ask him.
That's great.
Okay,
Anthony's
well,
asking a couple of questions, but I know my time's up, so I'm gonna go to mute and stop video. I'll answer his questions in the chat, and then I'm going to leave you to it, if that's all right with everybody. Thank you.
All righty. Madeline, thank you.
Thank you.
Okay, next up is Horst Schusko, who is director at Humber College Broadcast Broadband Convergence B2C Lab, Canada's first industry research lab exploring multi-sectoral applications of ATSC 3.0, including convergence of 5G networks. With over 30 years experience in the broadcast, film post-production, and music in the field of audio engineering and system design. Horst's work has garnered him an Emmy Award, 2 Emmy nominations, a Cinema Audio Society Award, and numerous international recognition. His journey included 6 years as a lead re-recording film mixer at Tadio Studios in Los Angeles. His interest in applied research has focused on emerging audio technologies, design, and related functionality in mobile SDK applications. Horst, take her away.
Thanks very much, Tony. I'm just going to share my presentation here. So good evening, everyone, and thank you very much for this opportunity to share some highlights and updates with you from the Humber College Broadcast Broadband Convergence Lab here in Toronto. I recall an opportunity last year, I believe it was September, so about a year ago, that we had a number of SMPTE members from the Toronto chapter join us at the annual SMPTE barbecue that was hosted at Humber. And we certainly welcome the SMPTE members, all of SMPTE members, back to visit Humber anytime to learn more about the lab's work. I also want to give a special shout out and thank you to Madeline Nolan, the president of ATSC, who you just heard present, for taking time out of her really busy schedule. I know probably just half how busy Madeline is, and I'm really grateful for her ability to join us this evening and share a lot of compelling insights into the latest developments of 3.0 on the global stage. For many of you, you might not be aware, but among the many titles and hats that Madeline wears, we're also very fortunate to be the recipients of her expertise as vice chair of our lab's industry advisory committee. So we're very grateful to Madeline for all her time and expertise. So for those of you not familiar with our lab, we're located in the Barrett Center for Technology Innovation at Humber College's North Campus. That's essentially Highway 27, just west of Highway 27 on Humber College Valley Boulevard, just south of Finch Avenue. The BCTI, as it's known, is a 93,000 square foot industry makerspace. It has platinum status, which essentially means it is a net zero energy emission environment. It produces all the energy that it requires through green energy. And it presently serves as a technological innovation platform for a number of multinational consortium partners that are involved in automation, robotics, and systems integration. These companies include the likes of KUKA Robotics, SEW Eurodrive, Magna International, and Cisco Canada. So in tonight's presentation, I'll share with you a lab overview along with several operational and research updates. Our research projects are sort of divided into 2 slices. We have R&D undertakings with industry partners, and we have applied research projects that are a number of steps ahead of where industry currently is operating and where it's foreseen that industry will need capacity gaps covered. So that's sort of the two prime areas that we cover off in the mission and vision of our lab. These are undertaken through a lot of active research work, participating in various ATSC groups, the CRC Communications Research Center in Ottawa, the University of the Basque Country in Spain, and the Electronics and Telecommunications Research Institute in South Korea. I'll also be sharing a few lab event updates, one that was recently held, which Madeline referred to, the open house, and a few that lay ahead on the horizon in the coming year. So I won't spend too much time on this slide because Madeline's already gone in depth on a number of aspects of the standard itself, but I'll touch upon a couple of key things that are worthy of mention. Moving down to the bottom part of the slide, the 3GPP release 18, which is due to be worked on starting next year, will explore the internetwork of 5G and IP-based DTT standards such as ATSC3. That's really exciting for us as we move forward in our convergence lab, because we're very much interested in providing support for industry stakeholders and for other research institutions that want to develop convergence plans. This could put a standard like 3.0 alongside other non-3GPP RANs that include Wi-Fi and satellite and Bluetooth, and can support convergence at the physical layer, the IP layer, or the application layer, or within the handset. So this kind of ability sets the true stage for convergence of broadcast and broadband systems that together can form a heterogeneous network, offering a more robust data delivery ecosystem, as Madeline alluded to. The B2C lab is Canada's first 100% front-facing industry research lab. It's specifically designed to explore multi-sectoral applications of the 3.0 standard, including convergence with 5G and the other global data delivery standards that I referred to, such as Wi-Fi and Bluetooth, etc. Our research teams include faculty members from Humber, external researchers, and Humber students who participate as research assistants. That keeps the students at the center of the experience and the innovation. We offer a low-risk custom innovation environment and work directly with industry stakeholders who are interested in developing new products, services, and solutions. A key component of our lab features a custom RF anechoic test chamber and full microwave test equipment. The chamber is spec'd down to 450 megahertz and is currently capable of operating up to 20 gigahertz with the option to move up to 50 gigahertz in the future. We also offer Canada's only ATSC3 over-the-air OTA experimental broadcast testbed that's supported across 3 experimental transmitter antenna sites covering the Toronto region. We have licensed both channels 22 and 28 for experimental use, and our testbed configuration supports the development of the intertower communications network that Madeline referred to, and which I will elaborate on in the project updates portion of the presentation. So the B2C lab itself operates through what's known as an Innovation Enhancement, or IE Build grant, that's supported through NSERC, which stands for the Natural Sciences and Engineering Research Council of Canada, and CFI, the Canada Foundation for Innovation. This grant supports and allows us to foster relationships and partnerships with industry that supports innovation on local, regional, and national levels. The lab supports commercialization through innovation, technology transfer into the marketplace, and supports the adoption of ATSC3 in Canada. Developmental research funding is matched one-to-one with industry partner contributions, and all Canadian partner contributions, both cash and in kind, are 100% tax deductible and fully shreddable, as they say, through the Scientific Research and Experimental Development Tax Incentive Program here in Canada. We do work, I should note, with US-based partners, and we welcome US partners and multinationals, both those that have a footprint in Canada as well as ones that don't currently have a footprint in Canada. One of the value adds in working with our lab is the industry partner retains all, I should say, the entire intellectual property component developed in the lab associated with the innovation, and they are free to commercially exploit the innovation anywhere internationally. So again, I mentioned the students earlier, but although we're an industry front-facing research lab, we really treasure keeping the students at the center of the experience. So those students do participate in paid research assistant programs that is supported by our grant, and they gain really invaluable skills in working directly with the industry partners. So just a couple of pictures to take us away from some of the text on the screen that you've been seeing. In the left image, you see the latest progress of our lab showcase build out. This showcase presents the lab in a really unique way in terms of curb appeal, if you will, for students. And that's attracted the interest of a number of them who've since begun working with us in the lab. And behind the showcase space, we have our operational sort of functioning area or secondary space that includes our RF anechoic chamber, which you can see there in the background, the microwave test equipment complement off to the left, and a growing collection of TV receivers, set-top boxes, and various receiver dongles that we're slowly acquiring to build up our own internal inventory. So having a broad range of receivers really allows us greater efficacy in verifying interoperability and specific R&D applications and use cases once we get involved with industry partners on specific projects. The left image here shows our main transmitter TX setup top of the top floor of the Barrett Center. This is on the 5th floor, so just below the roof level. This feeds our primary TX site atop of the Barrett Center. We have similar TX transmission rooms set up in our other 2 campus locations. And on the right side, you see our temporary NPR-M mast setup atop the Barrett Center. We're just in process of moving to our final mast heights, which will be roughly 10 meters, I believe, at the Barrett Center, 15 meters at Carrier Drive, which is our second site, which I'll show you shortly in a slide, and 10 meters down at the Lakeshore site. So moving on to some operational updates. Our 5G core network procurement is moving into its final stages. We actually were able to hold off on our procurement largely so we could understand what sort of intention might be looked at in terms of a framework and what kind of framework would be considered for convergence models with ATSC. So we were able to strategically sort of start to inform ourselves of how we'd like to move forward with the procurement of a 5G core. And we do expect installation and commissioning to be completed in the latter part of this quarter, which we're in right now, September to December. We may actually procure up to 3 5G cores to form essentially a macro network. That macro network is going to allow us to potentially simulate a nationwide 5G core scenario that will allow greater flexibility in supporting various aspects of 3.0 convergence development. As I just mentioned a moment ago, our 3 sites are now operational on NPRM mounts, but we'll be moving to final mounts before the end of the year. So hopefully before the Canadian winter sets in, we'll be up on our final masts. We've also been developing plans to expand our over-the-air testbed configuration to include a 4th experimental site co-hosted on top of the CN Tower here in Toronto through the generous support of both Rogers and Chorus Broadcasting and use of their infrastructure on the tower. And we're just awaiting approval from ISED on that as we speak. So here's a picture of the map that illustrates our 3 current TX sites sort of lined up or stacked up on the western quadrant of Toronto from north to south. So our main TX site and TX1 is located at the BCTI, where our lab is located. TX2 is about a kilometer and a half north at the Humber College Trades and Technology Center. And TX3 site is located down at Humber's Lakeshore campus at the corner of Lakeshore and Kipling Avenue in Etobicoke. And of course, as most of you may know, the CN Tower is the proposed 4th site noted off to the right. In terms of project updates, we have a number of active engagements underway, including with companies such as Avitech, Palmerex, research partners such as CRC, the University of the Basque Country, as I noted before, as well as our active participation in various ATSC groups. Those groups include the Tower Network Implementation Team, IT5, as well as the specialist group S43 on the development of a broadcast core network, and TG311 supporting ATSC3 5G harmonization. I've also noticed here in the slide some of our recently completed industry projects with partners including both Cinemedia and Sinclair Broadcast Group. I should take a moment just to note that our industry partnerships are very flexible and open, meaning a partner can complete a particular use case research project, develop, say, a prototype, a proof of concept, and that project would close. but the partnership may then include other use cases. So we have multiple partners that are working on multiple use cases with us, of which I'll share a few of some details with you this evening. We continue to build our research capacity in that respect in our lab, and we're working to bring on and onboard a few upcoming partners that are going to join us later this year and into 2024 to begin their projects. In terms of the active projects, we're presently working with Avitech Corporation, who many of you may be familiar with. They produce RF signal analyzers, sensors, and RF layer monitoring receivers for the global broadcast market and other industry sectors. So Avitech is currently developing what's called a high-capacity, ultra-long-range wireless backhaul solution across 2 or more transmission points using the ATSC3 PHY layer. So this project is designed to specifically support rural and remote internet delivery service that's most notably above the 70th parallel, and tie those services back to the backbone located in the southern regions of Canada. So the aim is to increase in the project the tower-to-tower distance from a line of sight perspective to an over-the-horizon perspective that could increase up to greater than 100 kilometers. Their innovation supports reducing the number of effective hops in a wireless terrestrial system, and the hope is that these could reach northern rural remote communities and connect them with IP backbone infrastructure that exists again in the southern regions without the logistical challenges of trying to lay fiber into those rural remote areas in the far north. Their project also offers integration capability with current ISP frameworks, as well as fixed and cellular technologies, including 5G infrastructure that's part of their innovation. We're also working with Avitech to develop an ATSC3 signal detection and mapping system using an aerial drone platform. So we're just in process with faculty and students who are developing an interface system to deliver real-time ATSC3 radio frequency signal measurements from an airborne device, from the device on the drone right to the ground in a live manner. That could be through LTE, through 5G, through Wi-Fi. That's still being worked out at this point. The drone R&D is sort of multi-purpose for us. It allows us to understand RF loopback signal behavior characteristics that are need to be analyzed in an inter-tower communication network design. They're also it's relatable to the Avitech project in many ways, because the Avitech ultra long range project is actually a form of inter-tower communication in and of itself, and that research work through the drone work informs our broader research with ATSC. The results through the drone measurement will also aid in understanding and determining zones of RF stability in this over-the-horizon capacity for transmission applications. At those over-the-horizon distances, there may only be an area, say, of 10–20% of the geographic area that has stable coverage in that reception corridor. So drone sensing allows us to optimize that positioning of transmitter towers and where the next tower could be located if we're trying to set up a transmitter tower system with new infrastructure for specific to support specific geographic areas. And that's really key, again, in terms of informing our research. We're also working with a company called Pelmorex, who operate the National Alert and Aggregation and Dissemination System that's known as the NAD system. The NAD system actually comprises the technical infrastructure of Canada's National Public Alerting System. So currently the NAD system receives an RSVP confirmation from wireless operators upon them receiving an emergency alert via NAD delivery. On the broadcast side, however, there's currently no RSVP confirmation pathway that's established for television broadcasters. So the goal of the project is to develop a mechanism to receive a confirmation that a broadcaster has received via the NAD system and confirm successful delivery across their platforms. So we're not touching the final televisions themselves, we're actually touching an RSVP confirmation or tagging that back from the broadcaster, if you will. This project's definitely going to support Pelmorex and help Pelmorex and the CRTC and territorial public safety officials to measure the success in the distribution of an emergency alert. That's very crucial. It will also determine any last mile distributor that may have experienced an issue with the dissemination of that broadcast immediate alert. Part of our active research with ATSC's Tower Network Implementation Team and joint research with CRC Ottawa involves the development of this ITCN network. So the aim of the project is to connect broadcast towers to form an IP and 5G based inter-tower communication network. This network will be designed to be scalable, reconfigurable, and support monitoring, data communication, and localized datacast and broadcast services. ITCN would also be capable of distributing broadcast internet data using an in-band full duplex technology on a portion of the broadcast spectrum. This would allow for distribution of TV programming and data through transmission and reception occurring simultaneously on the same RF band. The ITCN project also incorporates spectrum reuse through in-band distribution link, which facilitates backhaul of data between the towers. And these are technologies that are currently being developed by CRC Ottawa. More specifically, ITCN in effect pushes the broadcast gateway to the broadcast tower locally. And that allows for pushing up IP data into each TX site. So the broadcast tower in effect becomes a smart tower and facilitates this tower reconfiguration process for a broadcast network that can emulate a cellular network. So if we think about the CN Tower in Toronto, it really just spits out data to an infinite number of receivers. But if we can have broadcast towers speak to each other, then we make the broadcast system much more intelligent. It's also important to note that ITCN itself is essentially an agnostic system, and it can work with any DTT standard. It can work with DVB-T2, it can work with the Japanese standard, for example, and it does not interfere with the primary TV service or the foundational element that broadcasters are required to deliver for television service. It's also, in terms of the way it can move data, it can protect the legacy component for ATSC3 receivers that are already out in the marketplace. It also allows for the development of more advanced error correction for IoT data services. The IoT packets themselves may be a shorter packet size than a broadcast packet, and that would run separate from the TV service data on the ITCN network. Effectively, the TV receivers, front-facing next-gen TVs, are incapable of tuning into those data files. Moving on here, as part of our ITCN research, we're currently also working with the University of the Basque Country in Spain to develop a series of prototypes of what's known as a broadcast node. Many of you may be familiar that in a 5G tower base station configuration, there's something called the G node B that connects the 5G core network to the Access 5G NR. And each ITCN tower in the broadcast world for ATSC3 requires a similar, what we're referring to as a broadcast node, to connect back to a broadcast core network. The broadcast smart node essentially functions as a storage server, offers backhaul data, broadcast data, data carousel, and alternate data, as well as providing access to 4G, 5G in the cloud. So the aim is to develop complete control of a number of functionalities of the transmitter as part of a broadcast network system. A BC node at each tower would also provide local data upload and download, as I alluded to earlier, as well as other management functionalities, which could include SFN timing control, network control, monitor, scheduler, and access to the physical layer, and also to the ability to communicate with the other towers that are in the ITCN network. Our research roadmap leads from ITCN to ATSC's development of a broadcast core network, which Madeline touched upon. One can almost think of the BCN as a nationwide data engine where one or more broadcasters are enabled to operate across other networks to deliver content programming and data services into their own network, or again, into other parts of a broader network. In connecting broadcast facilities, the BCN will allow broadcasters to coordinate across this larger entity to create a marketplace that can deliver point to multi-point services in a distributed fashion. And the broadcast core network could be achieved via network slicing of a 5G core, which opens up a whole series of new business opportunities and unlocks a tremendous amount of potential. So essentially, the BCN is a cloud service that pipes data to the broadcast towers, and the ITCN feeds the towers. So from our current research perspective, we sort of see ITCN being part of the BCN clearly, but in reality, it can be an extension of the broadcast core network or a direct interface with the network. And much of that is still to be determined and would depend on where one would slice the 5G core network. The broadcast core network also allows individual broadcasters to interoperate as a layer to serve this BCN on top of their foundational delivery services. Looking ahead, we have several interesting upcoming projects, and one of them that's formulating is with the City of Calgary to develop Canada's first ATSC3 smart city. So Humber's lab team is planning to develop and experimentally deploy a series of broadcast datacast applications, including enhanced public emergency alerting services, broadcast emergency response network, and distance remote education services. So the city team is currently in the process of applying for an ATSC3 experimental license out in Calgary and developing a partnership with a broadcast partner in their locale to offer local transmission infrastructure support. So that's just in the works as we speak. Humber's lab will be providing the content source, the testing bed for generation of content here in Toronto, data encoding and encapsulation services that'll be fed to Calgary via a direct fiber link. So the idea is that we will send the content encapsulated through a gateway scheduler located in Toronto. It would light up an exciter in the Calgary broadcast market, and they could test and deploy experimentally in Calgary. I should note that this is an experimental setup at this point only. Moving on to a few event updates. So we hosted at our lab this summer on May 11th and 12th, our sort of first official formal open house. The event drew about 120 attendees or so, and we featured 10 very compelling presentations over those 2 days. These were provided to us very generously from a wide spectrum of industry leaders, research scientists, and partners. The presentations included an overview of the broadcast app that runs on 3.0, demo, which incorporated a demo of Humber's custom broadcast app that's being developed to support our industry and research partners. There's also updates on India implementation and the various number of topics here. I should note that those projects, those webinars, those presentations were all recorded and are all available on the Humber Lab website, which is b2convergence.ca. I should also note that we had also a really inspiring skill building student workshop that was delivered for Humber students by Madeline Nolan. So we're very grateful to Madeline for, again, taking a lot of her precious time to deliver a very custom message for students. On November 17th of this year, Humber will be hosting a very special ATSC3 broadcast positioning system seminar. This event will introduce and update stakeholders from a wide range of industry on current research and development that's being undertaken on a new broadcast GPS augmentation and backup solution using ATSC3. So GPS satellites, as we know, empower our infrastructure to function extremely reliably. And without these vital timing capabilities, both the Canadian and US economies would come to a standstill. So while most people think of GPS as a tool for navigation in their vehicle or in their phone, if you will, there's very reliable, the reliable delivery of time via GPS is so good that it's been adopted and enshrined in so many operations in critical mission services and vital infrastructure sectors in society. So there's a number of sectors, including the energy and power grid, wireless communications, the financial sector, transportation, first responder networks, public infrastructure, as noted here, critical defense, healthcare, public health, just to name a few. And all these sectors suffer this common risk. From a research innovation standpoint, the physical layer of ATSC3 is actually made up of a series of frames that are all announced by a bootstrap that's followed immediately by a preamble. And the preamble of each broadcast frame contains a nanosecond resolution timestamp. So that is sort of the core, the evolution of where all this research comes from, is this precision that's available in the 3.0 standard. So just a few kilobytes of information in the broadcast stream or in the separate PLP in a physical layer pipe from a single broadcast tower can offer precision time service. once you have 3 or more towers, you can determine position, time, and navigation, or PNT service, that could be delivered in the event of a loss or temporary loss of conventional GPS. So you may recall from the Google map I shared, once we have CN Tower online, we actually have the ability to triangulate between TX Site 1, which is BCTI, TX Site 3, which is Humber Lakeshore, and the CN Tower itself. So we're excited that Humber's testbed has the capacity to serve as an ideal ecosystem for future BPS R&D. More details will be forthcoming in the upcoming weeks, and we'll definitely keep SMPTE members posted about this event. Humber will also be hosting next year's IEEE Symposium on Broadband Multimedia Systems and Broadcasting for the first time in Canada. Dates are posted on bmsb2024.com, and further information will be available there shortly. For many of you, you may be aware that BMSB is the premier forum for presenting and exchanging technical advances in multimedia broadcasting, telecommunications, consumer electronics, and network technologies. And that brings me to the conclusion of my presentation today. And I wanted to thank you again for your time and interest in our lab's work, and also to thank Madeline for joining us this evening.
Thank you, Horst. I will just steal the slide deck back. It's like 3 clicks. Cool. So if anybody has any questions, please do enter them into the Q&A box. Horst, I do have one question for you. Just trying to figure out from your perspective and the lab and all that stuff, how is it being received by the community, i.e. the various sectors of the broadcast chain? Is it something that, because there's not too many labs, I think you're the only one, that actually services this kind of thing, and I find it intriguing that we as a community and a government that's allowed this to happen, and the Humber College Institute. I'm just wondering how it's being received. Is it something that wow? It's something that is you've been able to prove that it's something that is warranted and needed, and now everybody just you have an open checkbook.
Well, it's a great question. It's $1 million question. I have seen that there's greater interest growing amongst the amidst the broadcast sector with the broadcasters. I still think they're still determining what sort of resources that they would like to apply to ATSC3. I think there's also a lot of eyes on the US market to see how they're progressing with their transition to 3.0. 3.0 is a voluntary adoption in the US, not mandatory. So that changes perhaps the market dynamic somewhat in terms of pace and cadence, if you will. But I do think that there are a lot of opportunities, and we knew we were setting up the lab well ahead of the potential and even discussion of adoption in Canada of 3.0, but we wanted to be prepared with both technology clusters, ecosystem, and more importantly, to start to educate ourselves on what the standard is capable of doing. So although there's very early signs of interest, we're hopeful that those signs will continue increasing over time. The regulatory frameworks are also not quite aligned yet between Canada and the US, and that also poses some challenges. I'm not speaking as a policy expert by any means, and we're not a policy lab, we're a research innovation lab. But in the US, you are under FCC regulatory framework, you're allowed more than one service per channel. In Canada, we're still only allowed one service per channel. So the ability to datacast, to send data or non-TV applications still that capability does not exist in Canada. The concept that we're building with ITCN as a communications network could be deployed in the US because of the regulatory framework. That could not be deployed yet in Canada. So these are the regulatory challenges. I won't say challenges, but the differences in the regulatory frameworks that would eventually need to be aligned in order to allow ATSC 3 to be able to move forward in Canada. I
Interesting.
should say, I should clarify that by saying not so much for the standard to move forward in Canada, but for these other enhanced applications of ATSC.
Yeah.
I should make a clear delineation there.
Yeah, because it sounds, even from Madeline's presentation, that there's a lot of uptick, in that space. And I'm assuming that direct to mobile would be, well, that wouldn't be part of it, would it be? Because you'd have an ATSC 3.0 chip in your phone, and you would just be taking the signal or the transmission that comes off the tower. So it's not a subset of the main core distribution, correct?
Yeah, a lot of it would depend on how the standards converge and how that
Yeah.
application uses or utilizes convergence. But you could think of it simply as the ability with 3.0 to decorate the payload, to slice up the IP stream, the 6 megahertz bandwidth, to create new business models. And I think that's what's now being explored in the US, these data casting applications, and how that can provide these new models for broadcasters. So if we think about what may be evolving in Calgary, you have a city that's looking to find spectrum to deliver crucial services that require the support and partnership with a broadcaster. That's a new business model in effect for a broadcaster, whether they're sharing tenancy of infrastructure on towers or whether they're sharing or providing infrastructure for the city. Again, this is something new. So there are ways that we can explore potential through social innovation that may not necessarily just come through front-facing television.
So we do have one question here. Any update with the alert ready? Any update with the alert ready can with the TV auto power up and more than one alert?
I'm not very familiar with that particular area. I do know that in the PHY layer, in the physical layer of the standard, you are able to actually wake up a receiver. Beyond that, we're not really doing any research work within our scope right now on that. So I'm afraid I can't really comment too specifically on that aspect. Sorry.
Any other questions out there? I find it interesting in the Toronto market. I cannot get your signal, Orst, where I reside. But I think, as I said earlier, I think I found a bug in the TV, because it's not working the way that I would logically think that it would work. Because one of the things that, if not everybody is aware, that Canada is a region, US is a region, and you have to tell your TV what region you want to partake in. And if you want to see ATSC 3 in the US, you have to then tell your TV that you are a US citizen, I guess. So you just turn it to a US region. There's a whole list of different regions that are offered with the TV set. And once that sparks up, then your ATSC tuner can do what it's meant to do.
Right.
But I did do.
Oh, sorry.
Go ahead.
Sorry.
No, I was just going to say, I did do a channel scan. It did find one more channel. I'm going like, hey, that's going to be Orst. And then I realized I was in the US side. Then I flipped to the Canadian side, still nothing, but I'm still seeing the US on the Canadian side. So I think there's a bit of I think you're out there, but I just can't see you just yet.
Yeah, it could be also depending on your geographic location in Toronto. Our main TX site operates at roughly 400 watts. So we're probably pushing out, I'll say, roughly 20 kilometers or so around that in an operation. At Lakeshore campus, we're operating about 50 watts. At Carrier Drive, we're very low because we're so close. We're essentially co-located on those two sites. We're only about 10, 15 watts. So for us, we operate at very reduced parameters, but it's enough for us to calculate the research we need, or to move through the research roadmap. So it's also, we're also varying our power at times below that. So it could be that when you turned on, you couldn't actually pick up
Oh,
the
got
channels.
it.
We're
Okay.
operating primarily on 28 as our main channel. And
Gotcha.
we use 22 as part of our research to fulfill our research commitments and research capacity, if you will.
Yep. Yep. Cool. Now, just one more question for you. I know you from post-production world and things of that nature, and how do you find this technology? You know, it's you speak well of it, and it must be a joy waking up in the morning, just the way that you know, enamored in the technology. This is cookie cutter time.
Well, I think we have the blessing here in Canada, especially with our lab and our team, to work amidst a very auspicious company. The expertise of ATSC3, of Madeline, and the 150 or so member group companies, and the generous support we've received for such a wide span of the community, that's been tremendous for us. The ability for them to be able to come up and work with us is a gift for us. It helps scale up our understanding of the standard, but it also provides, I think, the ability for stakeholders in Canada to come into the lab with a little more ease and know that they can work in a low risk innovation environment. I find that really exciting, that we're working to offer things with in a very kind of friction-free environment. So there are a number of 5G labs across the country in Canada, but there are no labs that offer both 3.0 and 5G. So that's definitely exciting for us. So I think that if we can continue to provide that capability for stakeholders, it'll continue to be exciting for us. I think for me as well, I find it very interesting that my classical definition of television and rabbit ears and bunny ears is been shattered with ATSC3, because it's all IP coming over the air. So it's really no different than me streaming a service on my phone. I think what's challenging and what the industry is still trying to absorb is that traditionally carriers, the revenue stream for carriers has been with data, and broadcasters, the revenue stream was an advertising model with delivering content. But now the broadcast system is capable of delivering data. And I think that that's a disruption, but it's also affords a lot of new opportunities. So perhaps we're at the point of just gestating that and understanding what that means for the carrier industry and for the broadcast industry, and how they can work together to develop, as Madeline alluded to, a network of networks, a heterogeneous network.
Yeah. Yes. Bring your toys and play in the same sandbox. Cool. Alrighty, that's all I have in questions. I'm sure when we say good night, I'm gonna have like 3 more. So you know,
well, I thought I would just share, as I did at the outset in the first introductory slide, is that we're always welcome to host a visit from SMPTE members, either en masse as a group, or a couple of individuals, or just individual folks that want to come up and visit the lab. We're always more than happy to do that. The more we can help support education and advocacy of what we're doing and what the standard's capable of, that can spawn new ideas. So I spend a fair bit of my time supporting those types of conversations and introducing people to the lab. And I really enjoy doing that. I think that's what gets me up in the morning, as you alluded to.
Well, I agree with you. We were part of the September SMPTE meeting last year, and we took a tour of your facility, and it is world class. It is very nice. It's well laid out. You have all the nice tools. Willie's a great guy, and Willie is your technical guy. And yeah, and I just, yeah. So yes, I would concur with Urs that if you feel the urge, it's just a drive up 27, I guess it is, if you're in the city. But yeah, I thank you. I thank Madeline. I think she's offline, but thank her as well. and muchly appreciated. And I think from a SMPTE perspective, especially Toronto, you know what, we'll do this again because this technology is moving. I find it interesting that you know, there's something new that's percolating. So we'll likely you know, knock on your door again in the future.
Super. You're welcome anytime.
Oh, already. So Lawrence, I'm going to let you can steal the presentation.
I would like to thank Madeline and Horace for these amazing presentation. And Tony for preparing that meeting. So that's my 2 cents on my taking on it. Also, there will be a recording of tonight's meeting will be available on SMPTE YouTube channel. And Tony can tell me when. I don't know exactly, maybe in a week or in a couple of days.
Yeah, I think Peter has to do a little bit of house cleaning. We normally tip and tail edit it, but then you know, depending on workload and all that stuff, it should be within the week or so.
Okay.
And that's the SMPTE Toronto website, not SMPTE as in SMPTE.org, but SMPTE Toronto.
Also, I like to make sure that you invite all your friends to be a member of SMPTE. As you can see, we have a lot of new meetings and new topics and very interesting people. So you can become a member or become a friend, even if you're a student. On that, you'll find all our YouTube recording on the YouTube channel at goo.gl/olbwog, and it looks weird, but it works. I tried it. Also, up-to-date information, you'll find it on our website. And if you want to become a friend, also you can invite all your friends, and on Twitter, and you can send us an email and we'll look at it. Also, I like to say, be well, stay safe. That's a wrap up. Portez-vous bien, soyez prudents, c'est terminé. See you next time. Thank you very much.